We're going to explore Boolean indexing now. Booleans are true or false. And so what we're doing here, we're creating an n-dimensional array that has 7 strings in it. Bob appears twice, Joe appears 3 times in this list, and Will appears twice. And now we're going to ask a Boolean question. Which element in the names array equals Bob? And we get a true on the first instance because it equals Bob here. We get a true on the 4th instance because it equals here, and then everything else is false. Of course, we could put Joe in here too and change this and run it again, and it's going to tell us where Joe is true. The last 2 Joe is true, and the second element Joe is true. Let's change this back to Bob again. We're going to create a second array now. It's a 2-dimensional array with the first dimension being 7 and the second dimension being 4, and we're using our rand_n to do that. So these are going to be normalized around 0 with the standard distribution between 1 and -1. And so we have 7 rows and 4 columns. What Boolean indexing amounts to is that we can pass a value into here where names equals Bob. This value, of course, is the same value that we have here. It represents an array of 7 Booleans. What this is going to do is it's going to choose from the new array, it's going to choose from here the values where Bob is true. So it's probably going to return this value because Bob is true on the first value right there. And it's probably also going to return the 4th value, which is this 0.92. So 1.29 and 0.92 is probably what it's going to return. Let's see. Indeed, we have indexed this new array using a set of Boolean values. Furthermore, those Boolean values were derived from a completely different array. You may not be able to imagine a scenario where this would be useful, but it turns out that this is a pretty powerful tool sometimes to have at our disposal. Now we can reverse this as well and say, okay, any names that are not Bob, if we run that, then Bob is always going to be false, everything else is going to be true. And if we do that, if we run that, we can predict the results based on the understandings here. And there is an alternative syntax for the negative here, and that would be using this squiggly dash in this manner. Here we're saying that we can also use logical operators like and or when we're running a Boolean indexing operation. Let me run names again here, and let me also run the new array here so that we can see the data that we're working with. And when we get complex operations like this, it's often useful to put them in a variable so that our code is much easier to read and easier to work with. And here's a Boolean question. So this is going to return true wherever we have Bob or wherever we have Will. So in every case, it's going to return that. And if we run this, we get this list of Bobs and Wills. So obviously it's the first, it's the 3rd, 4th, and 5th. So here's the first, and we have that. And here's the 3rd, 4th, and 5th. And we also, if you notice here, have those. So now that we understand this Boolean indexing, we can actually set values here. In this case, we're not only retrieving these values from new array that match the values in names, but we're also setting those values to a 7. So let's run this and see what we get. Well, Bob occurs at index 0 and at index 3. And so we've changed those indexes. And more simply, we could say that anywhere that a new array value is less than 0, go ahead and change it to 0. And we can run this. And here was a negative number that got changed to 0. Here's a negative number that got changed to 0. There's 2 more here and here that got changed to 0. And 2 more negative numbers here and here that got changed to 0.